Hello everyone! What you're about to see is a speed build. It's a challenge to myself to see if I can build something more or less in a certain time frame. It is not a tutorial or a how-to guide. In fact, if it were anything even close to these things, it would be an anti-tutorial, a how not to guide. The reason for that is that I'm going to be ignoring best practices, I'm going to skip steps, all that sort of thing. Will that come back to bite me in the butt? Almost certainly. Additionally, I'll be throwing around terms without ever explaining them. So if you're looking for a tutorial on the topic discussed, you're probably not on the right video, although of course you're still welcome to watch. Maybe it still gives you an idea, maybe I can point you in the right direction down in the comments. Up to you. Either way, even if you're just watching for fun, or if you couldn't find anything else in any better video for what you're looking for, I hope you can still enjoy it. And let's just get on with it, shall we? Okay, so I need a distraction from Project Fall. I need to do something short that I can finish, and I'm going to do that by doing something I've never done. I'm going to try a one-day build. With an asterisk. What I'm going to try is to build a 12-key drum pad, a small drum pad, a small MIDI controller essentially that has 12 keys. Nothing all too fancy, that is our goal. Our goal is a 12-key, 12-button if you prefer, MIDI controller. Nothing too fancy, nothing too great, honestly. I'm not going to select for the right keys, I'm not going to do any debouncing. Well, I might, it depends on the time frame. There are optional goals, if you will. I might, if I have the time, build a nicer case. I'm going to build a base plate because that is kind of necessary to not just have a big bunch of wires hanging around. Yeah, that's something I'm going to do, is a base plate. I might build a case somehow, either machine it or print it. I might put in LEDs, and I might debounce the keys. It depends on how much time I have. It's going to be a one-day build, but because I have a day job, might be a two-day build, but 5 hours one day, 5 hours the other day, something along those lines. First of all, I'm going to do the cab for the base plate, just so I know where I can mount the things. Oh, I should probably mention the components. I am going to do the whole thing with some Arduino Nanos I have around here. These little guys, you've probably heard of those, usually for these. And I'm going to just use small PCBs to house some of these really cheap micro switches. These were 100 pieces. I think I paid like $5 for them, and it should work. I've done some preparations, or as some might call it, cheating. I do know that I can do that. I know that the Arduino can do that, and I have some code for a different but similar project already that I'm going to adapt for this thing. To be perfectly honest, I'm also shooting this out of sequence. The CAD for the base plate is already done. And yeah, I already have the PCBs sort of populated. They're not, they're not sorted down yet. They're just stuck in. But you'll hear me say that again. Right. Anyway, I'm going to take you guys upstairs now and walk you through the CAD process for the base plate. You're fun. So to get started, I'm going to model a dummy of the Arduino Nano I'm going to use. That's difficult to say. It has some pins on it, but these weren't soldered on well. It's from a different project, so they'll get removed. I'm going to model dummies of the PCB I'm going to use. They already have the buttons on them, but they're just sort of clamped in with their own little leggies. I have a reference of the Arduino Nano there. I have my calipers for anything else. And I have Fusion already open. Over here. So let's get going. Okay, that's the dummies done. I had some trouble with the patterns for the button dummies because I can't math.
But we're good to go, and now I'm going to align them in the planes and basically create the base plate from that. The main thing here is one that I needed the bore holes, so I know where to, well, put the screws. And the second thing is, which is basically why I made it this way, is I need to know where the USB port for the Arduino goes, so I can make a hole for that, potentially in the case later. I made the Arduino much thicker than it needed to be. I measured it with the pin headers, with the plastic parts, so I have plenty of space for soldering and that sort of thing. Next step, base plate. Okay, so that's the base plate done. Struggle a bit with some of the holes. I don't exactly like how these standoffs for the Arduino Nano are kind of cut off, but you know, it's the physical limitation of having the Arduino Nano's USB port stick out of the case, so it's kind of what I have to do. I also built in these little supports so that when I press the buttons in the middle, in the center of the PCBs, that the thing doesn't flex all that much. We'll see how it goes. I could have done it in one slot. I didn't plan this. Still works. I had built them and also aligned them with the buttons first, as you saw, and then I had to undo that because underneath the buttons is where the wires go, and I forgot that. Oops. Anyway, this should now work. I'm going to give it a last look and think to see if I can start working on this. And if it does work, I'll machine it. I'm noticing that these radii I probably can't machine, so I'll probably just do that as one thing. I'll see. I'll check it. Alright, that's the basic machining setup done. I've picked more or less random my box stock point. It doesn't really matter which orientation I'm using in this case. I'm going to use a adaptive clearing operation to get, you know, basically around all of the standoffs. And then I'm going to do, also the lip for the case. And then I'm going to do a contour around the outside, just so that, you know, it gets the nice radii, which I forgot to design initially. But thankfully, Fusion makes it possible that you can just add that and it'll just account for that if you regenerate the tool path. And then I wanted to drill it, but drilling doesn't allow you to use a face mill, even though that's possible. And then I had to use a face mill, but they didn't have a 1mm face mill, which is what I would use for that, or what I'm going to use for that. So I had to edit that, otherwise it wouldn't calculate the tool path. Alright. Anyway, it is now time to post that. And then set it up on the machine. And once that's done, I hope I can get started on the soldering. Yeah, the wiring. That's not a great setup, but it's what I have. I've clamped a piece of OSB board to my actual table, and then I bolted down a piece of plastic, which I hope is not acrylic, to that OSB board. I hope it's not acrylic because melting acrylic is very possible. I've just never had success with it on this guy. I'm hoping it's POM. It's for one thing, it's harder, or tougher. It doesn't break as easily as acrylic, and two, it's easier to machine. But it's a mystery plastic, and I've also not done a lot of plastic machining in the first place, and even less on this machine. We'll see how it goes. I do a little time lapse just to get you guys started, and then I'll take the camera because I have only the one, and do the soldering and the wiring and stuff. Yes! So I tried to reposition the camera while doing the lapse, which turned out not to be that great, and it's too short. I'm sorry. There's not much to see here. Okay, so this is probably going to be really loud since the mill is going, but I'm now going to do the desoldering of the pin headers that I've mentioned before. I'm going to wire in, or solder in the pins, the buttons, and I'm going to use some wire to put it all together.
Please note, I am going to wear my goggles because liquid metal in the eyes isn't very nice. And I'm also going to get my respirator because this stuff smokes a lot. Off we go.
A few moments later.
I'm going to use one of my new ones instead because this is going to take a while and this is supposed to be a speed build. So, expediency. Back to the hyperlapse.
Sorry for the breaks in the soldering, but the mill is almost done. I need to drill in the bores for the screws basically, but I thought, why not let's have a look at whether this even worked in the first place together. So I'm going to put you in the mill and then I'm going to vacuum away all the chips, and I don't know if you can even see me, but anyway, vacuum away the chips and then we'll see if this worked. Bump, bump, bump. That's a lot of chips. This is going to be loud. Well, it's really messy. There's still a bunch of chips up there, and I didn't account for the thickness of the material, so I don't think, yeah. Can you see that? Yeah, we're basically just halfway through, but that's okay. I'm either going to just run this program again with the Z height set 5mm lower, that should do the trick, or I'm just going to use a bandsaw. I don't know yet. Yeah, this is going to require a bunch of sanding. But overall it looks not pretty, but alright. Well, let's do whatever I just did. Okay, hang on. Turn off that thing. The final two operations went a lot quicker than I expected, but basically was just cutting out the thing and then drilling in. Obviously, having told Fusion to drill holes 5mm not only into the stock material, but 5mm into the actual thing, but only having a mill that has an overall length of 5mm, there are a couple of... Well, actually, I can only see one, what do you call it, sort of a chamfer, which you don't really want over here. That was material that was blown out and then got stuck to the mill. Otherwise, this looks pretty fine. I think this one went a little bit deep, and all the fuzziness I have to sand off, but you know, for never really having machined this material, it worked great. I like this material. I need to find out what it is and get more of it. I also noticed that I can push in the plastic thing, so the second cut around seemed to have worked great. Maybe I can just break this out. Yes, I can! And now I'm going to break it. That would suck. There we go. Yeah. Bunch of sanding left to do, but you know, that's probably just mostly chips that got stuck due to the heat, because I didn't cool it properly, because I can't. Anyway, I'll do that later, after the soldering, which we're going to go back to.